Hello everyone, welcome to Jack's tutorial. Today in this video we are going to talk about process scheduling algorithm shortest job first. Let's understand what is shortest job first CPU scheduling algorithm. The shortest job first SJF is a scheduling policy or algorithm that selects one process out of many with the smallest burst or execution time for execution. This algorithm associates with each process the length of the process next CPU burst. That means every process is associated with its CPU burst, and we are going to compare that CPU burst time with each other, and a process with smallest burst or execution time will be selected first for execution. When the CPU is available, it is assigned to the process that has the smallest or minimum CPU burst or next CPU burst. If the next CPU burst of two processes are the same, then FCFS scheduling or order of arrival of the process is used to break the tie. That means if two processes has same CPU burst time, that is 10:10, then the order of arrival will be considered for selection of the next process for execution. Now let's talk about types of shortage job first. So there are two schemes or two types, that is preemptive and non-preemptive SJF. So let's see one non-preemptive SJF. Once the CPU given to the process, it cannot be preempted until it completes its CPU burst. That means once the process starts execution, it will complete first and then the next process will be scheduled. That is nothing but non-preemptive SJF. Next scheme is preemptive SJF. If a new process arrives with CPU burst length less than remaining time of currently running process, then preempt CPU from currently executing process and give it to newly arrived process. Preemptive SJF scheduling is sometimes also called as shortest remaining time first CPU scheduling algorithm. One important point to note here is that in case of non-preemptive, if running process has burst time, for example 10, it has executed for 2 units, that means remaining time is 8, and if new process arrives in ready queue whose burst time is 4. In this case, in case of non-preemptive, the currently running process will keep the CPU till completion. It will not be preempted and control will not be given to the process having minimum burst time. That is non-preemptive. But in case of preemptive SJF, if the process with burst time 10 is scheduled, it has executed for 2 units, remaining time is 8, and new process arrived whose burst time is 4. So here remaining time of currently executing process is compared with the burst time of newly arrived process, and then the context switch will take place. Currently running process will be stopped and CPU will be given to the newly arrived process. That is nothing but preemptive SJF. In this video we will focus on non-preemptive SJF. In next video we will be talking about preemptive SJF. So let's understand how shortage job first SJF scheduling algorithm works. As I said, we are going to focus on non-preemptive SJF. To evaluate the SJF algorithm, we use scheduling parameters or criterias, that is waiting time and turnaround time. To understand working of SJF, let's consider the example below. Here the process along with the burst time is given as process P1 with 8, P2 with 4, P3 with 9 and P4 with 5. Here these burst time might be mentioned in milliseconds. That means unit might be specified or unit might not be specified. Here 4 processes are given along with their burst time, as I said, considering arrival time for all these processes as 0. In next video I will be showing the processes with different arrival times. Here we are considering arrival time for all processes as 0. So assuming arrival time for all processes as 0, we are talking about non-preemptive SJF. So after comparing burst time of all processes, we say that process P2 has minimum burst time, that is 4. So it will start execution at t equal to 0. So at t equal to 0, see here, at t equal to 0, process P2 has started its execution. Now process P2 will complete the execution at t equal to 4 because its burst time is 4. So at t equal to 4, process P2 has completed its execution. Now process P4, which is having next minimum burst time, will start execution at t equal to 4 and will complete the execution at t equal to 9 because its burst time is 5. So 4 plus 5 is 9. Process P4 started at 4 will complete at t equal to 9. Then process P1 with burst time 8 will start to execute at t equal to 9 and will complete the execution at t equal to 17. Because its burst time is 8, started at 9, so 9 plus 8, that is 17. So here we can see that completion time for process P1 is 17. And finally, process P3 with burst time 9 will start to execute at t equal to 17 and will complete the execution at t equal to 26. So here 17 plus 9 will give us 26. So here P3 process will complete at 26. That is completion time for process P3 is 26. We get the result as shown in the Gantt chart. This is nothing but Gantt chart for a given set of processes for shortage of first. As I said, we have the scheduling parameters, that is waiting time and turnaround time. So here let's calculate turnaround time for each of the processes given. For this purpose we need to use Gantt chart. That is what we have seen in previous slide. So let's begin with process P1. Arrival time is 0 and it started to execute at t equal to 9. See here, process P1 started to execute at t equal to 9. So process P1 completed at 17. See here, it is completed at 17. What is turnaround time? What is turnaround time? It is time from submission of process to its completion. See here, the arrival time is nothing but the submission time. It started to execute at t equal to 9. However, it is submitted in ready queue at t equal to 0. That is time from submission of the process to time of the completion. That means from 0 to 17. That's why turnaround time for process P1 is 17. Now, let's see second process, process P2 with arrival time 0 and burst time 4. As per the Gantt chart, process P2 has started at t equal to 0 and it completed at t equal to 4. That means it kept the CPU till its completion. So P2 turnaround time is 4. P2 turnaround time is 4. See here, submitted at t equal to 0, arrival time is also 0, completed at t equal to 4. So that means its turnaround time is the time from submission to the completion, that is 4. That is what we have written here. Let's talk about process P3 with arrival time 0 and burst time 9. So in this diagram we can see process P3 is submitted at t equal to 0, arrival time is 0, that means submitted at t equal to 0. See here, submitted means what? The process is arrived in ready queue. It is not the time that process has started execution. It is time when process is submitted in ready queue. Now as CPU is given to these processes, P3 will go in waiting state for this time. Right? So turnaround time is basically addition of waiting time plus burst time. So this is the waiting time. Okay, that means it is submitted at t equal to 0 and this is nothing but its completion time. So turnaround time for process P3 is 26. That is what I have given here. Arrival time is 0, started to execute at t equal to 17, kept CPU till its completion. P3 completed at t equal to 26. So turnaround time for P3 is 26. And finally process P4. P4 with arrival time 0 and burst time 5. Gantt chart, that is what we have seen. So arrival time is 0 and it started to execute at t equal to 4 and kept CPU till its completion. P4 completed at t equal to 9. So turnaround time of P4 is 9. See here, we can see process P4. All processes are arrived at t equal to 0. It got control at 4. and it is completed at 9. So time from submission to completion is turnaround time for P4, and that comes around 9 for process P4. Now turnaround time is over. We have to calculate the waiting time for each of the process. Simple calculation for waiting time is waiting time is equal to turn around time, TAT, that is turn around time, minus burst time. Burst time is BT, minus BT. Okay, so here Gantt chart is already we have. So for process P1, arrival time is 0 and it is started to execute at t equal to 9. So waiting time for process P1 is 9 because it is started at 9. So from 0 to 9 process P1 has to wait. See here, from 0 to 9 process P1 has to wait, and that become its waiting time. Okay, for process P1. Then for process P2, arrival time is 0 and it started to execute at t equal to 0. So waiting time for process P2 is 0. Similarly for process P3, arrival time is 0. It started to execute at t equal to 17. So that 17 becomes the waiting time for process P3. And finally for process P4, arrival time is 0. Started to execute at t equal to 4. That means from 0 to 4 it was in waiting state, and that's why waiting time for process P4 is 4. I hope waiting time calculation is clear to everyone. Now let's summarize the things. We have process P1 with burst time 8 with waiting time 9, that is what we have calculated, and turnaround time 17. For P2 these are the values, for P3 these are the values, and for P4 5, 4 and 9. Finally we have to calculate average waiting time. That average waiting time is sum of all the waiting time for all the processes. So 9 plus 17, 26, 26 plus 4, that is 30. 30 divided by 4, that comes around 7.5. And then finally we have average turnaround time, that is 17 plus 4 plus 26 plus 9, that comes around 56. So 56 divided by 4, that comes around 14. As the burst time is given in milliseconds, we are giving here units as millisecond for average turnaround time and average waiting time. This is all about non-preemptive SJF. In next video we will be talking about preemptive SJF. In this example I took arrival time 0 for all process. In next video I will be considering different arrival times for different processes, and we have to observe how it impacts in the calculation of waiting time and turnaround time. I hope SJF is clear to everyone. Thank you for watching the video.